Assalamualaikum and welcome to everyone. Today we are from Group 7 are going to present about Chapter 9 which about software testing. This is our group members. We have Atira Kerina, Lukman Hakim, Muhammad Ami Farhan, Arif Aiman, Fatin Shafika and me, Hadif.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Atira Karina, and I will proceed for the overview of this topic. First one is to develop testing, driven development, release testing, and also user testing. So we proceed with what is program testing. Program testing is used to check that the software works as intended and to find any errors. Next, artificial data is used to test the program and check if the output is correct. And program testing goals for this topic is to demonstrate that software meets requirements and discover incorrect or unexpected behavior. Could say that testing can show the presence of error but not their absence. Next, we proceed with validation and defect testing. The first goal leads to validation testing, which you expect the system to perform correctly using a given set of test cases that reflect the system's expected use. The second goal leads to defect testing. The test cases are designed to expose defect, and the test case in defect testing can be deliberately obscure and need to reflect how the system is normally used. So, what is testing process goals? First, validation testing to demonstrate to the developer and the system customer that the software meets its requirement. Next, a successful test shows that the system operates as intended. Second one is defect testing to discover faults or defect in the software where its behavior is incorrect or not in conformance with its specification. A successful test is a test that makes the system perform incorrectly and so exposes a defect in the system. The next one is an input-output model of program testing. So, input causing anomalous behavior and outputs which reveal the presence of defects. We give input to the system, then observe the output and compare it with what we expect. If output is wrong means there's a defect. Next, we proceed with verification versus validation. Verification is the software should conform to its specification. Are we building the product right? Process of checking that the software meets its stated functional and non-functional requirement. While validation, the software should do what the user really requires. Are we building the right product to ensure the software meets the customer expectation and goes beyond checking conformance with the specification to demonstrate that the software does what the customer expects to do it. Next is VNV process, which referring to verification and validation and apply to all stages of development. Why we use VNV? Because we need to find defects, check usability, build confidence, and get stakeholder approval. Next, how to perform VNV. First, software inspection static VNV. What it means, you're checking the software without running it. Next, how it's done. Review the system document, code, design, diagram, and so on. Next, what is the goal? To find the mistake early before the program is even executed. The next one is software testing dynamic VNV. What it means, you are actually running the software with test data. How it's done? You run the system, see how it's behaved, and check if the result match the expectation. And the goal is to see how the software performs when used in real world scenarios.
Inspections are applied to many stages of software, such as required specification, software architecture, UML design models, database schemas, and program, while testing are applied to program and system prototype. So, what is software inspections? It is a peer reviews where engineers examine the source of system with the aim of discovering anomalies and defects. Second, it may be applied to any presentation of the system, such as requirement, design, and to configure data. Software inspections does not require executions and an effective technique to discover the program errors. So, inspection effectiveness uh, it proved to discover more defects than testing, but it does not guarantee error-free. Then we bring a number of people with different experience of different type of errors. The team will approach offers greater coverage than any individual can bring. So then inspections can check conformance with a specification or verification more than verification, but not conformance with the customer requirements. And last, program inspection force the program author to examine the program in detail, So this often reveals more error. So this is about program inspections. First, what is program inspection? It is a peer reviews where engineers examine the source of a system with the aim of discovering anomalies and defects. Then, inspections do not require execution of system, so may be used before implementation. And that apply to any presentation of the system requirement, such as requirement, design, configuration data, and test data. And program inspection is also an effective technique for discovering program errors. This is for inspections and testing. It is complementary and not opposing verification techniques, and both should be used during the V&V process. It has been explained before. Then inspections can check conformance with the specification but not conformance with the customer's real requirement. And last, inspection cannot check non-functional characteristics such as performance and usability. So what is the inspections checklist is first, checklist of common errors should be used to drive the inspection. Then error checklists are program language dependent and reflect the characteristic errors that are likely to arise in the language. In general, the weaker the type checking, the larger the checklist. So the example is initialization, constant naming, loop termination, error, and bound. So this is an example of an inspection checklist. So for the fault class data faults, the inspection check we use sometimes have all constant bin name. Then for control faults, is each loop certain to terminate. And for input output faults, are all input variable used. So that's it. We question ourselves.
Okay, for model of software testing process, we have four circles. First test case, test data, test result, and test report. Okay, first circle is design test a case, and then we go to prepare test the data. For test the data, we have a prepare test data, and then run the program with the test. And then for test result, run the program with test the data, and then we compare the result of the case. And then last we test the report. For stage of testing, we have a three: development testing, release testing, and user testing. Okay, for development testing, we catch a bug and defect early in the development process. For the release testing, to ensure the final product meet a quality standard and is stable before deployment. And then for last, user testing, to get the feedback from a real user about the product's usability and certification. Okay, for development testing, we have a three testing. First, unit testing. Unit testing, testing individual models or component in isolation to ensure they function correctly. And then for component testing should focus on testing component interface. And then for system testing, testing the entire software system as a whole to ensure it meet the certificate specific requirement. Object class testing, complete test coverage of a class involved. Testing all operations associated with any object, setting and interrogating all object attributes, exercising the object in all possible states. Inherited makes it more difficult to design object class tests as the information to be tested is not localized. Okay, for automate testing. Automate testing is any software quality assurance process that use script and specialized tools to execute tests automatically rather than manual. Test automation framework, JUnit, to write and run the program test. And then for automate test component, we have three parts. First is setup part. Initialize the system with the test case, namely the input and expected output. And then second is call part. Call the object or method to be tested. And then for three part is acceleration part. Compare the result of the call with the accepted result. Okay, for unit test effectiveness, the test case should show that when use any expected, the component that you are testing does what it is supposed to do. And then we have two type unit test case. And first, the first of this should reflect normal operation of the program and should show that component were expected. And second is the other kind of test case should be based on testing experience of where a common problem arise. It should use abnormal input to check that these are properly processed and do not crash the component. Thank you.
We go to general testing guideline. First, we need to choose input that force the system to generate all error message. Second, design input that cause input buffer to overflow. Third is repeat the same input of or series of input numerous times to check their consistency. Then we force invalidate the output to be generated, and last, force computation result to be too large or too small. Then we go to component testing. Software components are often composite components that are made up of several interacting objects. So you can access the functionality of this object through defined component interface. Then, with testing the composite component should therefore focus on showing that component interface behave according to its specification. Then you can assume that unit tests on the individual object within the component have been complete. I give an analogy. If you want to build and test a gaming PC, so for component testing, you need to verify each part of the gaming PC works alone. Like CPU, we need to test in known working motherboard to ensure it boots. Then the GPU you can plug into another PC to check the display output. Then the SSD you can try to connect via USB to verify it's readable. So the goal is to ensure that all the components are not dead on arrival, or any other word, the all component works properly. Then we go to system testing. System testing during development involves integrating component to create a version of the system and then testing the integrating system. So the focus of system testing is to test the component or the interaction between other components. Then the system testing checks that components are either compatible, interact correctly with each other, and also transfer the right data at the right time across their interfaces. System testing tests the emergent behavior of a system. So I take the analogy of building and testing a gaming PC. So in the system testing where we test the assembled PC, we can check or test does the PC boots that involve interaction between CPU, RAM, and also motherboard and PSU interaction. Then we can check also is the GPU detected that involve GPU, motherboard, and also driver. Then we check either SSD store and load data. That's include SSD, motherboard, and also operation systems. So the goal is to catch any compatibility issue. System and component testing. During system testing, reusable components that have been separately developed and off-the-shelf system may be integrated with newly developed components. Then the complete system is then tested. Components developed by different team members or sub-teams may be integrated at this stage. System testing is a collective rather than an individual process. And in some companies, system testing may involve a separate testing with team with no involvement from designer and also programmer. Then we go to use case testing. The use case developed to identify system interaction can be used as basis for system testing. Each use case usually involves several system components, so testing the use case force this interaction to occur. The sequence diagram associated with the use case documents the components and interaction that are being tested. So we take the analogy of building and testing a gaming PC. So like first scenario, you want to play some high graphic games like maybe Cyberpunk. So you will check the FPS, the temperature, and also do you occurs any crash. Then second scenario, you try to video editing, try to render a 4K video. Verify the speed of and stability when you render the video. So like scenario 3, when you multitasking, like you run your Chrome or your Discords or your games in the same times. Test for any lag or any freeze when you use both of them together. As you guys can see, this is collect weather data sequence charts. This sequence charts demonstrates how use case testing works. So the component involve SATCOMs, weather station, ComSlink, and also weather data. So the interaction sequence like request report, acknowledge, report weather, acknowledge, send report, acknowledge, get summary, summarize, reply with report, and also final acknowledge. So testing will verify all this interaction happen correctly with proper data transfer between the component.
Alright, my name is Fatih Shafiqah binti Ali, and I will go next for the presentation, which is about testing policies. Okay, what is testing policies? In the short term, is testing policies are used to define the required level of the test coverage. Right, so which is it involve of the testing. Every possible scenario is impossible. Right, so we go for the example. For the one is all the system function accessed through the menu should be tested. And the second is about the combination of the function like text formatting. Like for example, text formatting accessed through the same menu must be tested also. Right. So the third is the user, where the user inputs is provided, or the function must be tested with the both, which is the correct and incorrect input. Alright, so the next is about test-driven development, or we used to call it as TDD. So what is TDD? TDD is an approach where the testing and the code development is interleaved. Alright, so the tests are written before the code, and passing the test is the critical driver of development. Alright, so the code is developed incrementally with a test for each increment. So we can only move to the next increment once the current code pass is a test. Alright, so TDD is originated in agile methods like extreme programming, but it is also applicable in a plan-driven development process. To be more exactly understand, we go for TDD process activities. Alright, first of all, we start by identify the increment of functionality. This should normally be small and implementable in a few lines of the code. Alright, so the second is we write a test for this functionality. This is as an automated test. Alright, so the third is we run the test along with all other tests have been implemented. Okay, we have not implemented the function, or otherwise the new test will fail, right? So the fourth is implement the functionality and rerun the test. Okay, and finally, once all the tests are run successfully, we can move to the next implemented functionality. So here is the flowchart of test-driven development, which is we start with identify the new functionality. After that, we write the test and we run the test. After we run the test, we have two other option, which is the testing is pass or fail. If the testing is fail, we go for implement the functionality and refactor. After that, we rerun the test. Once the test is successful, we can go for the next functionality. Alright, so the next is we go for the benefits of TDD. The first one is code coverage. Code coverage ensure that every code segment has at least one of corresponding tests. The second benefit is simplified to debug. And the third is regression testing, which is automatically but comprehensive regression. And the fourth is system documentation. The next is about regression testing. Alright, so regression testing verifies that recent change never effect of the previously working code, and manual regression testing is expensive, but the automated testing makes it more simple and straightforward, right? So the test must run successfully before the code change is committed or integrated.
We proceed to the release testing. So the purpose of this test is to ensure a system release is ready for external use beyond the development team. The primary goals of this test is to deliver specified functionality and meets performance and dependability expectations and does not fail during normal use. Release testing is typically conducted as black box testings. The basis of this test is to derive only from the system specification. So the release testing is a form of a systems testing. Let's compare release testing with other tests. First, we have the independent team, which performed by a separate team not involved in development. Then we have the system testing, aka development team, focused on finding bugs and defect testing. Then we have release testing. Release testing, aka validation team, do first check if system meets requirement, ensure system is ready for external use, and focus on validation testing. Emergent properties in release testing. The focus is for testing emergent properties like performance and reliability. Then the usage of the test is to the test should reflect how the system is actually used. Then we have stress testing, which is a type of performance test. The system is intentionally overloaded. The goal is to understand failure behavior. Then we have performance testings, which is gradually increase system load. Then the monitor when performance degrades. We proceed to the user or customer testing. The definition is to involve users or customers giving feedback on the system. It is still needed even after system and release testing. So, why is it critical? Because it involves real-world environment impact such as reliability, performance, usability, and robustness. This cannot be fully stimulated on lab conditions. There are many types of user testing. First, we have alpha testing. This test conducted at the developer sites. It performed by a selected groups of users. Users work closely with the development team. Then we have the beta testing, which involve wider group of external users. Software is released to allow real-world experimentation, and the users report issues to developers. Then we have the acceptance testing, which conducted by the customer. The goal is to determine if the system is ready for deployment. It is common for customer system. This is the acceptance testing process. We have defined acceptance criteria, planned acceptance testing, derived acceptance tests, run acceptance tests, negotiate test results, and accept or reject system. Key points in acceptance testing. Testing can reveal faults but cannot prove a program is fault-free. The development testing, handled by the software development team. Unit testing, which tests individual objects or methods. Then we have the component testing that tests groups of related objects. We have the system testing, which tests full or partial test systems. Then we have the independent testing. A separate team should test before customer release, which involve break the software. Use experienced and proven test case types and aim to uncover defects by intentionally stressing the system. Best practices for software testing. First, we have automated testing, which write tests that can be run automatically after every change. This helps ensure ongoing stability. Then we have test first development, which write tests before writing code. This ensures clarity of requirement and cleaner design. Then we have scenario testing, which involves inventing a typical usage scenario using this to derive test case. Then we have acceptance testing, which is a user testing process where the aim is to decide if the software is good enough to be deployed and used in its operational environment. That's all from our group. Thank you.